Hi, Math 9 students. Yesterday, or in the prior video, we discussed multiplying and dividing polynomials by constants. Now, we remember constants don't have a variable attached to them. They're just essentially numbers. But today, we're going to be multiplying and dividing polynomials by a monomial. And we know that monomials are going to have a variable and just one variable, right? It's going to be a coefficient in front of a variable. So let's look at the first example here where it says the expression 2c times 4c, it's the product of two monomials. Both of these are monomials, right? 2c and 4c. To help us build that kind of rectangle, what we do is we set it up around the outside. So this would represent the 2c, and this would represent the 4c's. Remember our monomials, we're going to have the long rectangles representing monomials, and then we're going to have representing the variables, and then the c squareds are going to be the bigger rectangles. So in order to make a shape that has this height and this length, or this width and this length, we would have to make a bigger square. So if you've got your 2c on the outside and your 4c on the inside, well, each one of these c times c's is going to equal a c squared. So in total here, we have 8c squares. So 2c times 4c is going to equal 8c squares. And you could do this with negative numbers as well. This second example has the same two c's here on the left side, but instead of having positive c's at the top, we've got the negative c's. So we've got four negative c's there. And all we have to remember here is for each of these particular shapes, we have to look at the signs for the monomials. So it's a positive times a negative. We know that the result is going to have to be a negative c squared. And all of these have to be the same. So the only difference between this one and the first one is that instead of having 8 positive c squareds, we have 8 negative c squareds. Now you can also include constants in these. This is a binomial, 2c minus 3, and negative 4c would be a monomial. So I don't know if it helps you to write, that's a monomial, and that's a binomial, which makes it different than the first question, which both of them were monomials. But the same thing still applies. We've got, if we're going to start with what's in the brackets here, we've got 2 c's, and then our constant, we've got negative 3 of these little squares. Then on the top, so this would be the 2c minus 3 part, and then on the top, we've got negative 4c. So we've got 4 negative c's. And again, you just have to do the multiplication, and then the shapes have to match. So here we've got, sort of the long side of the c and the long side of the negative c. Well, the only way that we can draw that shape is going to be a larger square that's going to be a negative c squared. And again, they all have to be the same. And then when we go down a little further, we've got these 3 constants here. Well, these constants are represented by the little squares, right? So we've got a long edge up on top, and then we've got sort of the short edge right here. And the only way that we can make a shape that matches both of these is going to be another one of these rectangular blocks. So this time we've got a negative c times a negative 1. We know that's going to be a positive c for all of these. So what we look at the end here is we've got 8 negative c squareds, and we've got, 412 positive c's. And if we think about the distributive property that we learned or reminded ourselves of in 5.5, if we were to do this symbolically, I'll just rewrite the question here, negative 4c times 2c minus 3. We have to multiply this negative 4c by both of the terms in the binomial. So the first thing we do is a negative 4 times a positive 2. Well, that's going to be a negative 8. And don't forget that the c is also part of this, right? It's touching the 4, and this c is touching the 2. That's, that's multiplication. So we have to do a c also times a c. Well, c times a c is c squared. Now we need to apply the negative 4c and multiply it by negative 3. Well, negative 4 times negative 3 is going to be a positive 12. And then a c, well, there's no variable here, so we just are left with the c. And we should get the same answer on both sides, and we do. For each of these ones, we're going to do what we did in the previous section, and we're going to just split it up and do symbolically on this side. And then we're going to do the tiles on this side. So the first one we've got here is a 3x by 4. Okay, so let's get in the habit of separating this out into a little grid. Okay, so we're going to do 3x plus 4 over here, and we're going to do 2x's up here. Well, 2x's, the positive, look like that. Now the 3x's are positive, so they're going to go 1, 2, 3. I'm going to run out of room here. And then I've also got 4 positive constants. Do I have room? I don't. Sorry, I'm going to have to resketch this quickly because I just didn't leave myself enough room. In fact, I might do it a little bit higher over here. Okay, so once again, I'm going to have the 2x's up here. There they are. And I got to have 3x's here. 1, 2, 3. As well as 4 positive constants. And then we just go and multiply one by one, making sure that the shape matches. Well, it's got to be that tall and it's got to be that wide. And they both have to be the same. Same thing on the next row. Doesn't really look like a square, but hopefully you get the idea. And then for these guys, they have to be short on this edge, and they have to be long on this edge, which means they're going to be the rectangles. And everything in this question is positive, so we don't have to shade any of these. And you should have the exact same thing in both columns, and you need to have the exact same thing in each row. So let's do this symbolically now using our distributive property. And hopefully we get the same answer. It's a good way to check, right? So we need to multiply the 2x by the 3x and also by the 4. 2 times 3 is positive 6. Okay, and x times x would be x squared. 2 times 4 is positive 8, and x, well, there's nothing there, so it's just got to keep the x. We get 6x squared plus 8x. So let's go back to our tile version and let's see if that makes sense. How many x squareds do we have? Remember the big ones here? Those are the x squareds. Looks like there's 6 of them to me. And I don't have room to write it in here, but each one of these is an x, right? So we have 6x squareds and we have 8 x's, so our answers match. Okay. And the next question here, and hopefully I don't run out of room. I might have to write a little bit smaller. Okay. Symbolically, we've got a negative 2x up here, and we've got the 3x, negative 3x. Erase that. Negative 3x plus 4. So negative 3x is going to be 3 rectangles, and they are going to be shaded, the negatives. And then I got a positive 4, so I got 1, 2, 3, 4. I'm going to run a little bit into the next row. Sorry about that. I don't think I can draw any smaller. And then a negative 2x at the top here, so that is going to be 1, 2 of those rectangles. They're negative. So what we've got here is now we can just multiply the the row by each column. We know we've got a longer rectangle here and a longer rectangle there, and we also know that if it's going to be that shape, it's a negative times a negative. We know it has to be a positive, so we're going to leave these guys as positive x squareds, and it's the same for the first 3 rows. Sorry, I'm not looking like squares there, but hopefully you get the idea. And then we've got the narrow edge of a constant, right? These are just constants, 1, 2, 3, 4 of them, by the long edge of one of these x tiles. And that's going to mean that it's got to be short and then long. So it's going to be a positive times a negative, which means we have to shade these guys in. So these are x tiles that need to be shaded in. And I'm sorry, I'm going to run into the next question, but I just can't write any smaller. Give myself a bit more room here. Okay, now let's go to the other side and let's do the symbolic version, which usually doesn't take nearly as much time. And we'll use it as an opportunity to A, practice the distributive property, and B, check to make sure that our pictorial model is correct. So if we're going to distribute a -2 times a -3, we know that's going to be a +6, and an x times an x is x squared. And then we've got a -2 times a +4, so a negative times a positive is going to be a negative, and we've just got the one x there. There we go. Obviously, it's much quicker to do the symbolic version. Let's check to see if this answer matches what we've got on the other side. We've got 1, 2, 3, 4, 5, 6 positive x squareds, and then we've got 1, 2, 3, 4, 5, 6, 7, 8 negative x's, so that one checks out. All right, so this says the division to divide, oh, we're talking about division now. To divide a polynomial by a monomial, we reverse the process of multiplying. So we're still going to have something that looks the same, but instead of starting on the outside and working to the inside, we're going to start at the inside and one of these sides and try to figure out the other one. So when we're trying to divide something, this is really what we're trying to figure out here. So if we look at this particular fraction here, we've got 8x squareds. So these are all the x squareds. And then we have to break that up by 4x. So 1, 2, 3, 4 of the x's there. And we have to figure out, okay, we have to figure out what this column is going to be. So for per row, what have we got in here? So we've got to, how are we going to break up basically, how are we going to break up this big rectangle so that it matches both up here and here? Well, clearly we have to have a rectangle, otherwise it's not going to match this side, right? So if we broke it up, what we're left with is 2 of these x tiles here, which means our answer would be 2x. So there are 2 guiding x tiles, and these would be the guiding x tiles. And we decided that after we broke up this into that, the result over here was 2x. Okay, now we're going to divide a binomial by a monomial. So we've got -6w squared, and we have to break it up into 3w, right? That's part of the question. So basically you would probably write the 3w first before you wrote these. So there's the 3w, and somehow we've got to break up -6w squared. So if we're going to break up 6w squareds, clearly it has to go 1, 2, 3, 4, 5, 6. And then for the 9w's, same thing. We have to have 3 in each row. So we've got to figure out over here, what do we have left? Well, in order to make the large square, we need to have one of these and one of these, right? And the same thing here. And how are we going to make these rectangular blocks? Well, we have to have the small square there, and those are represented by constants, right? So what do we have left over here? Well, first off, we've got a negative in the answer, or in the -6w squared, and we've got a positive w here, which means a negative divided by a positive. We know that this one has to be a negative as well. Same thing here. Okay. We've got a positive w and a positive 9w's, so these are the 9w's, right? Positive w and positive 9w's, so these all have to remain positive. So let's just see what we've got left here. We've got 2 negative x's, or sorry, these are w's, not x's. Change the variable on me. So these are 2 negative w's, and then we've got 1, 2, 3, 4 positive constants. So if we do this symbolically down here, remember we've got to divide the numerator by the denominator, which means the 3w has to apply to both the negative 6w squared and the 9w. If we divide negative 6 by 3, we're going to get a negative 2. If we divide w squared by w, we're just left with w, and that's from our Unit 2, the exponents and the exponent laws. Now we'll go to the next one. If we've got a 9 divided by a 3, well, that's positive. And then we've got a w divided by w. Well, anything divided by itself is just going to be 1, so we don't have to bother writing anything after that. It would just be 3 times 1, which is 3 anyway. And, as usual, we use this to check the top part. I thought I had 4 of these constants down here, but I only had 3. I had 1, 2, 3, so this would actually be plus 3. Once again, it becomes very important to use our symbolic to check our tile, or our tile to check our symbolic. Considering I have so much trouble drawing with this pen, it's a good handy little check for me as well. Alright, so let's do some more of these. We're going to do tiles and symbolically for both of these to practice, and then obviously we're going to do some more practice in the textbook. We'll do the symbolic on this side. I'll try to draw the tiles out over here, make sure I've got enough room. Okay, we're dividing by 2 m's, so that's a monomial. So we'll draw our monomials on the top, and then we know we're going to do this little chart thingy. And then inside, we have to represent negative 10 m squareds. Well, if they're m squareds, they have to be the big squares. And there has to be 10 of them, and I have to separate them into 2 rows. So the only way I can do that, oh, goodness grief, I'm running out of room again, is by putting 2 in each row. So that should be 10 of these, and they're all negative, so I'm just going to shade them in. Starting to look more like rectangles. Don't want that. And then our goal, because this is the 2m up here, m and m, our goal, those are all negative m squareds, our goal is to figure out what goes on this side. Well, if we're going to break up this square shape, we've got a length there, and we're going to have a long edge there, which means we're going to have 1, 2, 3. Oh, that's looking like a square, not a rectangle. Here, 5. My rectangles are getting smaller as I go down. So I'm going to have to break this up, and I've got a positive here and a negative here, which means these guys are all going to have to be negative. And then you can check by just kind of going opposite and doing the multiplication. Does it make sense that a negative tile times a positive tile equals a negative tile? It does make sense. So in the same way, does it make sense that a negative tile divided by a positive tile equals a negative? Yes, it does. So what are we left with over here? We've got, these are all m's, right? M, 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 M. And how many have we got? We've got 5 of them. So symbolically speaking, we should get the exact same answer. Negative 10m squared, and we're going to divide that by 2m. These are both monomials, right? There's no plus or minus after the negative 10m squared. So we're going to take negative 10 divided by 2 is going to give us a negative 5. And m squared divided by m, we can cancel one of those m's and left with negative 5m. Put my negative sign over there because, again, these are negative tiles. I'm not going to make the same mistake I made on 5 and draw out this one because it'll take up a lot of space. So we're just going to solve it symbolically, and I'll just rewrite it because I ran out of room. So 30k squared minus 18k, and then we're going to divide that all by negative 6k. So it's important to remember that we have to divide by, both of these terms have to be divided by a negative 6k. So let's start with the 30. We've got a positive 30 divided by a negative 6 is going to give us a negative 5. And then we've got a k squared and a k. So that's just going to cancel to 1k. Okay? Now, just if you're having a little trouble wondering, or if you're having a little trouble with that part right there, if the k squared divided by k, just think of it this way. It's k squared is just k times k. and then it's divided by k. Well, we can just cancel out one of those, and all we're left with is the 1k. So if this is from Unit 2, but if you've forgotten why we divide k squared by k and get k, that's why, because k squared is really just k times k. All right, so let's go to the other side. We've got a negative 18 divided by a negative 6, so that's going to be a positive. And then 18 divided by 6 is 3, and then k divided by k, well, those will just cancel. So that's what we're left with, negative 5k plus 3. Okay, this is just the opposite of multiplication. And as long as you take your time and go carefully, and clearly I was moving a little too quickly through some of these examples because we caught some errors with our checking. And you shouldn't have too much trouble with the textbook questions, but if you do, as always, send us an email and we are happy to try and help you through it. Good luck!